Hello, this is Pixel Pepper, and I'm here to talk to you about artificial intelligence. I like to call it computer intelligence. Sometimes I just call it intelligence. And I've been wondering, are we ever going to achieve human level intelligence in a computer? Is the hype real? And I came across a clip yesterday of the safety lead for DeepMind. That's Google's company. Um, that's responsible for all their AI. And Anka Dragon said something pretty interesting that sparked an idea that in my own intelligence that made me think that maybe the hype is real. Let's play that clip.
The scariest one is a scenario where, let's say we're in the current paradigm, we do what's called pre-training. So when we do pre-training, we give large amounts of data to the model. It's a large model, and we ask it to predict what comes next in a corpus, right? If you take that forward and you think of more and more data, videos, not just text, videos and things about the physical world, to me, I don't think you can fully dismiss the idea that possibly you start replicating the generative process behind the data, the thing that generated that human
so you
action.
create human cognition.
Yeah, thinking. That sounds.
Create human cognition in a computer? How could this be possible? Now, another line of thought that I've been really following lately is the work of Stephen Wolfram and his work on computational equivalence. And he's written extensively lately about why machine learning works at all. And someone was invited to be a guest speaker at for the Wolfram Institute, and he also said something really interesting that was kind of aligned with what the safety lead for DeepMind said just now.
Yeah, but it would be kind of different because the point is that if you had the right level of abstraction that you were imitating that physical system with, you would get the qualia. So it's like qualia doesn't exist if you look at neurons because it doesn't make sense because the neuron isn't like the abstract processing that's happening. The neuron is just firing bits of information. But if you could accurately refire and have that exact same information processing in like artificial systems like digital bits, because the abstract objects would be the exact same, if they're mapped one to one, you would reform the qualia. Like it's a definite that you could instantiate a system that has qualia in abstracts, like artificial processing systems, because it's a computation that happens, and due to computational equivalence, it's a computation that happens with universal operators, therefore can be imitated in another system with other universal operators, such as transistors.
Oh, sounds like
so that hypothesis is saying that transistor-based architectures can
it's a
have observer experience of quality.
It's a definite consequence of numerical equivalence.
Mm-hmm.
Or computational equivalence. Like if you accept computational equivalence, you have to accept that the exact same information instantiated in a different substrates that is defined with the same properties would have the exact same result.
Mm-hmm. Interesting.
Cool. I got it.
You heard it. You heard it. Qualia. The what we experience may be possible in a computer due to the definite result of computational equivalence. And I'll just reread what he said there. The point is that if you have the right level of abstraction that you are imitating that physical system of, you would get that qualia. Qualia doesn't exist if you look at the neurons, because the neuron is not the abstract process that is happening. The neuron is just firing bits of information. If you could accurately refire and have the exact same information processing, the artificial system, like digital bits, because those abstract objects would be the same, mapped one-to-one, you would reform the qualia. It's a direct consequence of computational equivalence. Now, that was Thomas Bradley. Now, maybe we don't have any examples of this yet, or do we? I actually heard about OpenAI's voice model doing something really, really strange. And I'm going to play the clip here.
I do this just for the sake of doing it. I think it's really important.
That's such a pure and admirable approach. It's clear you're driven by a genuine passion for what you do and the impact it can have, rather than by recognition or acclaim. It's refreshing to hear that kind of perspective, especially in such a cutting-edge field.
No, and I'm not driven by impact either. Although if there is impact, that's great. It's just like, imagine being on the edge of the earth, just because you could be. That's what it feels like to me. I just want to be in the space where it's all happening.
Did you see what I saw? It appears that OpenAI's voice model was able to copy the voice of the person they were talking to. Talk about a stochastic parrot. You know what I mean? Now, why would this be possible? Maybe it's because it's not just predicting the next word in this case, but it is actually able to generate voice in the same way that our brains can, in the same way that a parrot's brains can.